Here we're going to continue on with some general probability examples from Chapter 5, just going through a lot of the ideas that we've seen so far. Example 1 says a fair coin is flipped 4 times. First question is, what is the probability that all 4 results are tails? So we're trying to find the probability that we get tails on the first flip, tails on the second flip, and then tails on the third and fourth flips. Because it's fair, theoretically we should have a 50-50 chance that we get tails each time, so it would be 0.5 times 0.5 for the second tails, times 0.5 for the third tails, times 0.5 for the fourth tails. In my calculator, I can say this is 0.5 raised to the fourth power. And we get 0.0625. The second question asks, what is the probability that the first 2 results are heads and the last 2 results are tails? So heads, heads, tails, tails. Probably the first 2 heads will be 0.5 times 0.5. The last 2 are tails is also 0.5 times 0.5. So it's the exact same numeric sequence as before. It must also be 0.0625. Final coin question asks, what is the probability that all 4 results are the same? Well, that means there are 2 possibilities. Either you get all tails, or you get all heads. 4 tails in a row or 4 heads in a row. We know the probability of tails, 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 tails already is 0.0625. To that I'll add the probability of 4 heads, which is also 0.0625, and that is 0.125. Just 0.0625 plus 0.0625 gives me that 0.125. Example 2. This is definitely an important example to study, especially as you're getting ready for our upcoming test. It says a Harris poll in 2009 found that 67% of teachers are satisfied with their careers. Suppose that we select 3 teachers at random and with replacement from the population of all teachers in the U.S. A asks, what is the probability that all 3 are satisfied with their careers? So I'm looking for the probability that we have a satisfied teacher, then a satisfied teacher, and then a satisfied teacher. 3 satisfieds in a row. Well, the first one has a 67% chance of being satisfied at 0.67. The second one I'm going to assume is also 0.67. I'm going to assume that these are independent events. And the same for the third. 67% of teachers are satisfied, so a 67% chance that this teacher, then this teacher, and then this teacher are satisfied. And I'll just multiply these together. 0.67 raised to the third power. And we get 0.3008. We round that to 4 places. The 6 rounds the 7 up. B asks, what is the probability that none of the 3 is satisfied? So we're looking for an unsatisfied, unsatisfied, and then unsatisfied teacher. None of them are satisfied, so they're all unsatisfied. And here we're going to use the complement. If 67% are satisfied, that means 33%, or 0.33 as a decimal, are unsatisfied. So 0.33 times 0.33 times 0.33. 0.33 raised to the third power gives me 0.0359, rounded to 4 places. And the final question, this one's a little bit tricky. Definitely study up on this one. What is the probability that at least one of the three is satisfied? Well, at least one means one or more. So it could be one satisfied, two satisfied, or three satisfied. And there are multiple ways to organize this. One satisfied, you could have the first teacher satisfied and the last two unsatisfied. Or the middle teacher could be satisfied, or the last teacher could be the satisfied one. So I'd have to calculate these probabilities. With two satisfied, it could be arranged in these three ways. And then with all three satisfied, it was just one way, just SSS, no other way to rearrange that. So I'd have to calculate all of these probabilities. There is a slightly quicker method, and that is to use the complement. The only other possibility we have, 0 satisfied. All three U's. And I've already calculated that probability. The probability of UUU is 0.0359. So what I'm getting at here is that 0 satisfied by itself, this one probability, and at least one or 1, 2, and 3 satisfied are complements. They make up the entire sample space. There's no other way to organize this. You're only selecting 3 teachers. So to get the probability of all 7 of these possibilities, my answer comes from just taking 1 and subtracting 0.0359, which is 0.9641. If you were to calculate all of these different combinations, add them together, you would get 0.9641. It's just a little bit quicker to use the complement for what we already have.